All right, from our exam review, all the solving systems pieces. In this set of problems, it says specifically use elimination. If I tell you what to use, that's what I'm expecting to see. In number 36, what I like is that I can see that I can eliminate the y's because I have positive 3y and negative 3y. So as I work down, because elimination is just, I'm going to put these equations together working down. 2x's and x is going to give me 3x. 3y minus 3y is going to give me 0. And I'm going to get to 3x is 15. Adding 13 and 2 gives me 15. I'm going to divide both sides by 3, and I'm going to find out that x is 5. I'm partway there for solving my system. I need to figure out what the y value is that goes along with that. If x is 5, I can put it in. I'm going to use the bottom equation. I could use either. I'm going to subtract 5 from both sides. If you use the top equation to solve, you should still get the same y value I do. 2 minus 5 is going to be negative 3. Y is equal to 1. My solution is 5, 1. If I were to graph it, that would be the point of intersection. I'm going to move over to number 37. There's multiple ways that you can start. There's actually two 37. Sorry about the numbering error. There's multiple ways you can start number 37. I think that the simplest way really, like I'm looking at my y's here. I've got negative 5 and negative 5. If one of those was positive, life would be good. I'm going to take the top equation, multiply it by negative 1. I could do it to the bottom. Same thing would happen. And now I'm going to be looking at the system. Negative 4x equals negative 7 plus 5y. Distribute that negative in to the right-hand side. 8x equals 9 minus 5y. My elimination of the y's is now in place. Negative 4x plus 8x is 4x's. Negative 7 plus 9 is going to give me a 2. When I divide both sides by 4, x is going to be a half. I'm going to use the bottom equation. 8 times a half equals 9 minus 5y. 8 times a half is 4. That's not what I wanted to do. I'm going to take 9 away from both sides. Negative 5 equals negative 5y. If I divide both sides by negative 5, I'm going to find that y is 1. My solution is a half, comma, 1. Now, in 37, second one, what would be the first step in solving if you intend to use elimination? Use a complete sentence. Well, I don't have these things lined up. I don't have my equal sign lined up. So that's the big thing there. Like, you know, you could tell me about, like, I want to multiply one equation by 2 or something like that, but not until you rearrange it so they're both sitting in the same order. Maybe I shouldn't, in order to put them both, I don't know. You should first subtract 2y from the top equation in order to put them, they're not in standard form, to put them both in the same form. It's not standard form. Put them both in the same setup. Your equal sign needs to be lined up. And then I could go on and do some other stuff, but that's what I was getting at there. If I'm going to use elimination, my equal sign needs to be lined up. These systems, the easiest thing to do is set them equal to set them into a y equals mx plus b. And I say that, let me go over here and do number 39. Remember that y equals mx plus b. My top equation, I'm going to graph in blue. I'm going to start on the y-axis. The y-intercept is 1. The slope is 2. From the y-intercept of 1, I'm going to do a rise of up 2 to the right 1, up 2 to the right 1, up 2 to the right 1. And I could grab a ruler here. I'm going to, somewhere, got one. Oh, got it. Cool. And then I go graph my other one. I like these. Again, I started here because they were both in y equals. This one's going to start at negative 3. It's got the same slope. Up 2 to the right 1. Up 2 to the right 1. So what's the solution to this graph? Right. We have parallel lines. To this system. This system has no solution. Now, let me use the idea of I want a y equals mx plus b in order to graph for number 38. I'm going to start with my bottom equation and subtract x. My bottom equation, I'm going to write it as y equals negative x plus 2. Start at 2, down 1 to the right 1, down 1 to the right 1. My slope is negative 1. That's my bottom equation. I hit that one first just because it was simpler to solve for y. Took x away and that was that. Now this equation here, so 3x minus 2y equals 6. If I take 3x's away from both sides, I'm going to have negative 2y equals negative 3x plus 6. And then I'm going to divide. Hold on. Which one? This one? There's nothing wrong with this one. I'm going to divide everything here by negative 2. There's nothing wrong with this one either. So y is equal to negative 3 over negative 2 is going to leave me with a positive 3/2 x. 6 divided by negative 2 is going to leave me with minus 3. I'm at negative 3 on the y-axis. My slope is up 3 to the right 2. Up 3 to the right 2. And so my solution looks like it's sitting at 2, 0. My solution sits at 2, 0. Now, number 40 wants us to solve 39 mathematically. I don't tell you how. I would just, they're both y equals, set them equal to each other. If they're both y equals, then set them equal to each other. And we already know something about this, that there's no solution. I expect this to be a little funky. Huh. This is what we see. An untrue equation means there's no solution. I'm not getting why x gets eliminated. X gets completely eliminated, and so I'm getting an untrue equation here. So actually, this example addresses this piece of number 41. Infinitely many solutions to a system you would solve mathematically. So if we have infinitely many, solving mathematically, let me just say this. We have a foldable about this, I feel like. Solving mathematically produces what kind of a equation? Produces a true equation like 3 equals 3, but no x and y values can be found. And infinitely many, I just want to remind you, is when you have two equations that are the same line. Yeah, infinitely many means you got two equations of the same line. Two forms, you know.